Hello everyone, my name is Banu Prakash. Welcome to the channel Detour Learning. In this video, we are going to start the subject Strength of Materials. This is the first video related to the subject Strength of Materials. In this video, we are going to introduce what the subject mainly related to and also dive into some of the topics like properties of the materials. Let's dive into the topic. Strength of materials is a branch of engineering that studies the behavior of the solid objects under stress and strain to predict failure and ensure the safe structural design. In this subject, we mainly discuss about how the materials respond to external loading by examining the stresses. For this, we have to know what are the properties of the materials. First point, we have to know the properties of the materials, and after that, we have to know how the materials behave with respect to different types of loadings like tensile loading, compressive loading, and shear loading. After that, in this subject, we are also going to know about the stress strain curves. These are used to determine the internal forces that are developed due to external forces applied on it, and also how these external forces leading to the deformation of the materials. After that, once we are knowing how the behavior of the materials, we can easily design the structures. By knowing the different types of properties and the behaviors, it is very easy to design the structure. Finally, once we are knowing the stress strain curve, we can know what is the failure point, and also we will do some of the failure analysis so that we can keep the structure safely within the failure limit. The main principle of strength of materials is to ensure for the design of vast range of structural compounds. These compounds are like bridges, buildings, etc. Now let's dive into the topic. We are starting the topic called properties of the materials. Before knowing the properties of the materials, let's know what are the different types of materials we daily see in our surroundings. There are the materials like metals, ceramics, and polymers. The examples of the metals like aluminum, silver, iron, gold, etc. And also ceramics, right? We can see these ceramic materials in kitchens like utensils, and also polymers, which are the part of our daily life. And also these materials are classified based on their appearance, physical properties, and their applications also. Now let us know how, based on the appearance, these materials are classified. First, there are lustrous and non-lustrous materials. Lustrous materials are those which give a shiny look to us when they are cut. For example, we can see diamond, aluminum, gold and silver. Some of the metallic materials are lustrous in nature. Mostly metallic elements are lustrous in nature. Non-metallic like polymers and ceramics. This may give dull surface when they are cut. For example, we can see wood, graphite, and the polymers also. They give the non-lustrous appearance. Now we can see the properties of the materials. There are basically three properties of the materials like physical properties, mechanical property, and chemical properties. First one, we can see the physical properties. These are the properties which we can see, which we can touch, we can feel how the material is. That is called the physical properties. Some of the physical properties are like how the material is like hard or soft, what color it is visible, and also is it transmissible. We can know is it transparent or translucent or opaque objects or opaque materials. Here we can see some of the examples for hard and soft materials. Diamond is a very hard material which is on the top of the hardness scale. And some of the metals like sodium, if we see sodium and lithium, these are soft metals or soft materials that can be cut with knife. And we can see these metals like sodium, lithium, when they are cut, we can see the transfer section will give a lustrous nature that gives a shiny look. After the completion of hard and soft materials, we can see the physical properties color. There are different types of colors in the different types of materials. Like in the metals, we can see aluminum, silicon, and gold, silver, copper. Each one is giving different types of colors based on their chemical bonding or based on their appearance, their arrangements of the atoms. Each element will give, each metal or material will give different colors. Next one is transmissibility. Transmissibility is nothing but allowing the light from one side to other side. If you see glass bottle, it will transmit a large amount of light from one side to other side. Whereas if we see wood or any metal, the transmissibility is very less. Here is some of the examples, like if we consider as a polymer, a plastic cover, it is translucent, which send some of the light from one side to other side. If we see a glass bottle or glass material, this will be a transparent material. And opaque materials are those which will not allow any kind of light from one side to other side. That is wood. And after completion of the physical properties, now let's dive into the mechanical properties of the materials. First one is the strength. Mechanical properties are those properties that are tested in the lab so that we can know how the uh, how the material is resisting with respect to the changes that are doing in it. These are not based on the physical appearance, but these are based on the tests what we have done. First one is the strength. Strength is the ability to withstand applied force without failure. If we apply any force on the material, then there will be some internal forces that are developed against this external load applied. Based on the external force, if the force increases, after some time these internal forces will stop, and there we can see the deformation. Up to maximum how much external force we can apply so that the structure withstand without failure, that is called the strength. Second mechanical property is hardness. This is the resistance against surface deformation such as scratching. This hardness can be done by hardness test equipment like Brenner test, Rockwell test, and Vickers test. There will be a hardness scale in which different items have different hardness, where we can see which material will be on the which material is harder than which material. This hardness scale is also called as Mohs hardness scale, where we can see diamond is at the top of all the materials. These are the materials ranking from 1 to 10. At the top, at number 1, we can see there will be a talc in the scale. At number 10, we can see diamond on the scale. When we uh, when we rub each other, each the materials, the harder material will remain without breaking or without scratching. The softer material will scratch on the harder one. Based on that, we can know the hardness. Next mechanical property is the elasticity. Elasticity is the ability to retain its original shape or size after deforming force is removed. If we can see any material, when the load is applied, we can see some of the deformation in that material. After, after the removal of the load, if the material gains its original shape, then that property is called the elasticity. If we take example as rubber band, once we apply the load, this will be deformed very large. The deformation will be very large. After the removal of the any load, then the rubber band will come to its original position. This is called the elasticity property. And also each material have different types of different values of the elasticity. Steel metal will have different type of elasticity. Copper will have different type of elasticity. Based on the elasticity we use in different kind of applications. And also fourth property is plasticity. Plasticity is the ability to permanently deform without fracturing after certain stress is applied. The example is clay. If you consider clay, After applying the load, this material will be deforming permanently. But if the load increases continuously, the permanent deformation also will increase, and suddenly we can see the crack in it. Here, the load up to which we applied before the breakage, that is called the plasticity. Clay is one of the best material which is very plastic, that can be permanently deformed with the stress compared to the different materials. So these are easily molded and easily shaped so that we can make them as a some of the statues or some of the small toys, or we can make based by using the clay because of the plasticity property. Next property is the ductility. Ductility is the ability to to be stretched or drawn into thin wires without breaking. Here we can see, this is the ductility test. We can see, if we consider any metal, if we are able to make the metal into thin wires as thin as possible without breaking, then that property is called as the ductility. For example, ductility of copper is very high, so that copper can be made into thin wires which are used in our electrical appliances, electrical circuits, because of this ductility property. Our next property is malleability, ability to hammer or reel into thin sheets without breaking. This is the property where a metal can be hammered or rolled into thin sheets, very thin, as thin as possible. For example, we can see the gold. By using a single biscuit of gold, we can make into different thin sheets or different ornaments which can be rolled into different types of designs based on the malleability property. And also we can see in some of the dishes we are using gold foil. That is also due to the ability to be getting into thin sheets, that is called malleability. Next property is toughness. Toughness is ability to absorb the energy and deform plastically before fracturing. In the stress strain curve, we can see that we are continuously applying the stress on the material. By continuously applying the stress, we can see how the material is deforming. Here the toughness is that once we are applying the stress, this stress is absorbed by the material as a form of internal forces, and the stress absorbed or energy absorbed is known as the toughness. If you see, there will be two types of materials like ductile material and brittle materials. The energy absorption will be different for both the materials. Here the toughness of ductile materials will be more compared to the brittle materials. In the figure we can see that the green line represents the ductile materials and the red, orange line in the sustain curve represents the brittle materials. Here the toughness is the area under the stress strain curve. This is called the toughness. Here we can see the elements like steel element. Here once we consider the specimen, the failure of brittle materials and failure of ductile materials will be different. The way of failure. Here we can see the specimen changing its shape and also elastically changing its shape, and we can see a 45 degrees at the breaking point, and it can able to resist more stress compared to the brittle materials. And also ductile materials will give the warnings before failure, but the brittle materials will not give any type of warnings. They fail directly. This is the toughness means. Next one is brittleness. Brittleness is tendency to fracture with less or no plastic deformation when subject to stress. Before we saw that in ductile material there will be plastic deformation, means there is necking that is formed in the materials while the stress is applied. There we can see some of the strain in the materials. But whereas in the brittle materials we cannot see any necking forming or any strain that is happening in the brittle materials. That is the main reason why the structure will fail suddenly without giving any warnings. Example, if we consider a glass, when we heat a glass, it will not strain anywhere. It directly breaks into or shatters into pieces. This is the main example of brittle material. And also if we consider cast iron, when the maximum point of failure reaches, it directly fail without giving any plastic deformation or without any warnings. So in the design of structures, we mainly use the ductile materials like steel. So these are the different types of properties of the materials. With this, I am going to conclude this topic and this video. Let's see in the next video. Until then, bye bye. Keep learning. Thank you.